Good afternoon. Thank you for coming. As I mentioned in our presentation last night, the unit you are about to see was specifically designed for this demonstration. It is a unit that's larger in size. That's intentional. We're trying to be as transparent as we possibly can and to really show the core components of the system. When you look at this and you'll see it, you're going to see a system that has all of the components spread out so that you can see the entire power chain. You can see that flow of energy. And please, if you have any questions during that, please don't hesitate to ask them. The other thing I'd like to point out is that you have the opportunity to see this unit. We're going to be removing all of these doors and panels on the exterior of the unit. They are not properly adhered to on the unit right now, so we removed all the bolts for the ease of removing this during the presentation. With that, please allow me to introduce Mr. Michael Galt, who will walk you through the entire unit.
Very nice to meet you. This is our SolarGEN. This is a renewable energy power source. It's a 5 kW unit. The unit is completely scalable to your needs. It's modular. It can go wherever you need it to go. And as you can hear, I'm not having to speak. I probably hold the microphone close to my mouth, but I'm not having to speak extremely loud. It is extremely quiet. This unit is larger than the 5x5 that we were talking about, the unit coming in. And as you'll see, once we take all of the doors off, we spread everything out. We wanted you to be able to see every single wire, every motor, so that there was just a complete transparency and you were able to see the power flow from start to finish.
I think there's one additional point I'd like to make. We had a decision to where to connect this unit to. 2 weeks ago, we were going to connect this unit to the grid, which had a specific configuration. In consultation with NREL, the National Renewable Energy Laboratory, they certify alternative energy. It's very similar to other entities all around the world that validate and certify a unit for operation and certify that the technology works. In consultation with NREL, we determined that the best way to show this test is to use what we call a load bank. Rather than connect to a grid or to a building where the load may be variable, where the load may have the opportunity to be dispersed, and you can't really quantify what the actual demand on the unit is, we chose to do what we believe and what the regulatory bodies that test and authenticate systems choose to do, and that's to test it on a load bank, something that provides the utmost highest standards of testing. So once again, what you're going to see throughout the entire unit is a much larger unit, which actually has a load bank installed inside of it, once again adding to the size of this unit. So please remember, this unit, when it's actually fielded, would be smaller. We'd reduce the container size, the outside compartment, to a 5 feet by 5 feet by 5 feet system. With that, we're very honored and happy to take and show you the remainder of the system and just how exceptional it is. Before doing so, let me give you one thought of concept. If you were to talk about the amount of energy coming into a unit, you can talk about one unit, one measure of unit, regardless of what that is. And if you were talking about any other system, you would say, boy, if we can get 1 unit of measure in and we can get 0.7 or 0.8 out, that would be pretty good. If you could achieve 1 unit in and 1 unit out, that's exceptional. In fact, I don't quite frankly know anyone else that can do that with the exception of us. You're about to see a unit that you will see for every 1 unit in, you get 6 units out. That's exceptional. Hold your thoughts and hold your questions on that because you're going to see how we actually do that. With that, please, Mike.
Okay, we're going to go around and what we're going to do is actually pull. You've gotten to see the unit. We're going to pull all the covers off of the unit all the way around and get inside of actually what's going on. So what we have here is our 2 battery chargers for our 2 banks of batteries. And what we've done is we've simulated renewable energy. The unit requires a small amount of renewable energy, be that solar, wind, geothermal, whatever is most readily available at the site. What we've done to simulate that is we've run a cord into the unit, and that cord runs up, and it is providing 340 330 to 340 watts of energy to the unit. So what we have, we're going to come on around, what we have is, as Doug mentioned, rather than doing a grid, we have put an electronic load bank that they would use to test any other kind of loads. This unit is computer programmed and will be drawing power, exact specified power that we want off of the unit so that we can really monitor and be within very precise parameters. When we come on around, so right now, let's go back to this. We have 330, 340 watts of power coming into the unit right now. And what we've done is we've brought in a flat screen to show exactly what's going on with the unit. And as you can see right now, our total wattage is 1.48 kW, or 1,490, almost 1,500 watts going out. So right now we're looking at about a 4+ ratio, maybe not quite a 4+ ratio on the loads in and loads out. Well,
and if I may add to this, right now we're increasing the demand on the unit, and you're going to see this change. It's starting to go up as we do. And what I'd really call your attention to is the amount of voltage coming in, the amount of watts coming in, and the amount of kW, kilowatts, going out, meaning the amount of energy we're producing. So if I can call your attention to the actual feed, live feed of what is coming in, once again, this represents 368 watts of renewable energy coming into the system. That is all that this is coming into the system. This other screen that you were just shown shows 2.21 kilowatts going out. That is about a 7-to-1 ratio at this point. 8-to-1. Now the ramping unit is going up even more. So as you watch this number climb right here, we'll take this up over 3 kilowatts. And at the same time, we'll call your attention to the input. And you'll notice two things. The watts hovering somewhere around 350 to 375 in terms of watts coming in from the alternative energy source. And look at that screen now. You're seeing 2.8 rising to 2.9. That is almost a 10-to-1 ratio. Almost a 10-to-1 ratio. We're hovering somewhere in around 1-to-9 ratio, 1-to-10 ratio on the energy in, energy out. That's exceptional. As I talked before and spoke of, think of that. If we were talking about a conversation of 1 unit in and 1 unit out, that would be an amazing conversation. No one else can do that. But we're doing 10-to-1. 1 unit in and 10 out. Mike, please.
Okay, so we're going to walk around the unit and kind of just describe all the different components of the unit. So as I mentioned, we have the power coming in, and that power is going into our motor. And it's from the motor, it is turning a generator, and that generator is charging a bank of batteries. We then have, from the bank of batteries, this is all DC power, and we're able to run it into an inverter. This is typical inverter you would see in solar. This inverter converts all the power to AC, which then runs it into our power quality box and turns it into usable power. What we then do is we draw off of the system. So we have a second set of batteries that are plugged into our power coming off of our system. And what those are doing is they are recharging this second set of batteries. So, Doug, why don't you hold the microphone for me a second? Sure. Okay, so what we have is batteries cannot charge and discharge at the same time. So you have one load, one bank of batteries is running the motors and discharging. The other one is charging up. And at some point we switch, and the other bank of motors runs the motors, and the other battery bank charges up. So it's a constant switching between the two banks of batteries. The bank of batteries and that was one of the questions we had in a previous simulcast. One of the batteries we had was, questions we had was, how do you charge the batteries up off the unit? They're literally plugged into the power queue in the outgoing power. So the batteries and the load bank are what's coming off the power queue. The motors are not creating any heat at all. As you can see, we're running at very, very low RPMs. So we're not, heat is the enemy of energy creation. Very low maintenance. As you can see, there's hardly anything moving here. In fact, the noise of the motors is much less than the noise of the load bank. This will not be a part of the final unit. That would be what we would be going into the grid. As you can see, an extremely quiet, extremely cool system, which we think is going to have very, very low maintenance, not hardly any moving parts. As I'd mentioned, we're producing renewable energy. Renewable energy can tend to be a little dirty sometimes and not the cleanest power in the world. We've added our power quality box to this unit. This power quality box is why we're almost at a unity of 1. Our power factor here is 0.958, 96%. We're almost at unity here with our power factor. So, as you mentioned, Doug.
Yeah, so that's a really, really important point. The power factor of 1, that's the most pristine, pure energy that you can obtain and that you can utilize. In this particular case, we're looking at energy that is so pure, and the collateral benefit of that is that electronics want that. Coming out of the standard grid, you could get as low as 0.6, 0.7, which is considered dirty power. Electronics do not like that. With a power factor of 1, the other collateral benefits that you get is that you enable the unit to produce energy so pure that electronics, the life expectancy of those electronics lasts longer. The maintenance issues for those electronics and other equipment last longer and are less expensive. So in addition to providing some exceptional power in literally wherever it's needed, this system produces energy that will actually save you money on the maintenance side with all other equipment. Anything plugged into the energy source that we're supplying will run much better and will be less wear and tear on it as a result of the power factor. Please.
Also, what we've got up on the screen now is your total harmonic distortion, your noise on the line. As you can see, we're looking at 3.2% harmonic distortion. Again, exceptional. Not only are we at unity, but we're extreme. Our harmonic distortions are almost nothing. Typical grid, you would see a 20%, especially in the odd deviations. We're not just producing power, but producing exceptionally clean power. Out of the power queue goes into a breaker box, and this is where we're able to plug in our other battery charger. And this is the battery charger that is being charged off of the system here, as one bank of batteries is being charged up while the other one is drawing down to run the motors. And the power is also coming out of the power queue and going into our load bank so that we can have exact draw. And this is sucking an exact amount of juice out of the unit as we go along.
We hope you've enjoyed the presentation today on the SolarGEN system. We are open to your questions, and please feel free to email those. You can respond now to the webinar site, and we'll be happy to get you an answer back. With that concludes our presentation, and thank you very much for your time and attention.